Next week, we're going to be looking at a new type of sequence known as geometric. So before we do that, we're going to review arithmetic sequences from last semester. So an arithmetic sequence is a special type of linear function, all right? With our regular linear functions, we know that we have continuous data. It can go with a domain of all real numbers. But for a sequence, the domain starts at 1, 2, 3, 4, 5, etc. We call those the counting numbers. The reason we call them the counting numbers is because we're looking at the first term, which in this case is 6, the second term, which in this case is 10, and the third term, which in this case is 14. And that pattern would keep on going, but we're only looking at terms 1, 2, 3, not terms 1.5 or term 0, term 2 and 3/4, nothing like that. Whole numbers, 1, 2, 3, 4, etc. All right. And so that's the big difference between a sequence and a regular function. Now, because we're starting with term 1, we don't talk about the y-intercept like we do with a linear function. Instead, we talk about the first term, which we call a sub 1. So in this case, our a sub 1 is 6. That is the value that we're starting with. It is literally the first number that we see in the sequence. The common difference is very similar to the slope. It's your adding or subtracting pattern. So in this case, I see that to get from 6 to 10, I am adding by 4. To get from 10 to 14, I am adding by 4. So my common difference is 4. We can see that on this graph here, this is increasing by 4 every single time from point to point, okay? Now, we have two ways to write sequences. One is known as the recursive formula. The recursive formula literally shows us what comes next. So I've got the general format over here, and you're literally just plugging in the values for a sub 1 and d, the common difference. So in this case, when I go to write my formula, I'm going to say that a sub 1 equals, and that first term is literally 6. So I'm going to say a sub 1 equals 6. For my next part, I'm saying what comes next, basically. A sub n is equal to a sub n minus 1, which is the previous term, plus, and in this case, remember my pattern was 4. 6 plus 4 is 10. 10 plus 4 is 14. So I am going to say plus 4 in my equation. That formula is really good at telling you what comes next. The other formula is the explicit formula. So the explicit formula, I've got the general form down here. Again, you are just plugging in the first term and the common difference. We will eventually start simplifying those, but we'll do that next week. For now, we just need to write this general format. So I'm going to start by saying a sub n equals, and then it's my first term. Well, my first term is 6. That's literally the first number I see. Then it's plus my common difference. Well, we are adding by 4 every single time. So in my equation, I'm going to say plus 4. Then I'm going to take that 4 and I'm going to multiply it by n minus 1 because that's going to account for the fact that we are not starting at 0. Instead, we're starting at 1. So that is our arithmetic sequences. You guys are going to finish up the practice on Delta Math, and then we'll be ready for the geometric sequences next week.